Good morning from Brussels. It's me again, Jean-Louis. I'm going to do another video in a series of videos I did for two or three purposes. First is to find a bit of a better way to present things, not using PowerPoint, but something else. I don't know what that something else is. But I think, yeah, whiteboards or notebooks and then a more dynamic presentation. Where I sort of use the whiteboard to highlight things might work better. The second purpose is yeah, to just have a video online for recruiters. I'm currently in between jobs, and I often find myself in a position where you get a very general or a very specific question, and yeah, I tend to get into the weeds, and either I deal with an HR person or else with a technology specialist, and and somehow I don't get across. So I want to take my time here to in these videos to talk a bit at length and do what you should be doing in a situation like that, is say, okay, well, what's your question, and what exactly do you want me to address? Because yeah, things are complicated. They always are. At the same time, they are remarkably simple. So let's get going with it. I'm gonna focus a lot on technology, but at the same time from an ICT management point of view. I said my audience that I have in mind are really managers. I said it a couple of times before. I think as a manager, not necessarily an ICT manager or an ICT project manager, but as a manager in general, all organizations deal with technological change, and they need to understand it. And any project that you're gonna do to increase the maturity of a department or your organization as a whole, it's gonna involve technology, automation. And so what's been nice is that in the last 10, 20 years, 30 years, a lot of thinking has been done on how to automate the automation process, right? This is the fourth industrial revolution. So my take on that, my worldview in terms of making sense of that is the one I always present here. You need to constantly have, and that's not only for ICT managers, but for every manager, like a process view on your organization, and then a project view. There are templates for that in every business. Especially in the ICT management business or management practice, I would call it. But I don't want to confuse with ITIL for terminology here. But yeah, you need to sort of have a business process model in mind. In the back of your head always. What are the permanent functions I need to manage, and how can I continually improve these? And then at the same time, you need to do stuff that's not business as usual in a projectized way. So you're going to define a change management project or a technology project or whatever kind of project, and yeah, you need to manage that project. You need to resource it. You need to track it. You need to evaluate it. So that's the project management cycle. Plan, implement, and evaluate. Specifically for ICT management, I said it's not rocket science, but yeah, there's a lot of tooling around it that help you with improvement of your processes, and also help you to manage or automate, I would say, service deployment, new services that come online in the service-oriented architecture. So that's what I put a little bit here. We have the ITIL service operation model. And that's from version 3. It's quite old, from 2007, I think. I still like it very much. I think ITIL version 3, I just did my version 4 certification, and I will talk about that, has the advantage that you can sort of represent the basic core functions in your ICT organization on one slide. Let me make it a bit bigger. We have functions like request fulfillment, incident and problem management, which I think are the other three core functions. I came out of a year-long, a nice experience with an organization focused very much on that, with the appropriate tools, an issue management system. Like for me, I will talk about that. I liked it, but it's not as powerful as ServiceNow, for example. Around it, you'll have facilities management, which is supported and related very much to event management. What is the state of your system? What are loads? You have monitoring tools. You need to manage your virtualization architecture. I'm going to talk about that. VMware is not obsolete, but a lot of changes are there in how you can virtualize, and that's got to do with the infrastructure as code. Revolution, I would say. You have your stacks, .NET, or what I would call not an Oracle stack anymore, but a Java stack. I will explain why. You need to manage your IT assets and continually manage, sort of an inventory of, what is there. So you can use a tool as enterprise architect. Let me clean up my notebook. Hopefully that works. Yeah. So there's a lot of tools around these permanent functions and processes in your organization, and you need to understand these tools, and it takes a while before you are really familiar with them. And I cannot say I'm familiar with all of them. I just know what they do, and I crucially know, I think from my experience, is that you need to keep that manageable and practical. It's one of the guiding principles. Make sure you have a holistic view, and that each tool does what it does within the objectives that you have set for that tool and that particular business function. This is where I'm going to talk about ITIL 4. I said I did my certification. I will be frank. So ITIL, the new thing about ITIL 4 is the idea of functions and processes got replaced by what they call management practices, and they got, and that's one I don't like. They have not less than 34 different management practices, and it's a vague concept. And I found ITIL 4 version 3 is like a nice framework, and then you can get into the weeds. ITIL version 4 is like the opposite. They don't get into the weeds. They don't talk about tools. They don't go into very much detail of how should we do incident and problem management. They give a lot of definitions. What is a known error, and a lot of recommendations. The best thing about it, version 4, I think, are these 7 guiding principles. It's like the 7 habits of highly effective people. That's kind of nice. Focus on value, on added value. Keep things simple and practical. Think holistically. Don't get stuck in analysis paralysis. Move iteratively, and a few others. But these are sort of the main things. They embody, like what I like most as a management principle. I mean, there are 2 of them. Think big. Think holistically. Start small. Get going. And make sure your pilot or your minimum viable product is a good one, that you learn from it. And then once you've got the magic formula right, then scale fast. So think big, start small, scale fast. And I think if you remember that, instead of a whole set of guiding principles, then you can get somewhere. The project view now. This is the other thing about ITIL 4 is, I said, I like to sort of, in your head, doing a project, doing things in a projectized way is very different than, continual improvement, working on your processes. And you need to combine both. You need to free up organizational creativity and time and resources to do both process improvement, improving what you're doing, and then starting new projects that will bring your organization hopefully to the next level within a certain technology or within a certain sector or something totally new that you want to do. There, I think things haven't changed. So we work with tools that are far more capable now than 20, 30 years ago. But basically, what you think about, and I'm copying here a figure from a guy whose nickname is Salaboy, but it's Mauricio Salatino, and it will make a lot of publicity for him. He's a young IT guru promoting very much what is now referred to as cloud native development, which is not necessarily in the cloud, but agile, services oriented, and more in particular microservices oriented. So he has this figure. He starts his book with it. Let me make it a bit bigger again. He basically says, this is what it's all about. Oops. A change happens. And a change is it's still very much the same. It's maybe your environment changes. When you talk environment, then I'm really talking, your test, unit test, integrations test, your staging environment, and your production environment. That might change. In your production environment, maybe we want to do migration from our data center to the cloud, all these kind of big environmental changes, or smaller environmental changes. We want to do apps on phones. That's a change of the client platforms. And so I won't because this presentation is going to last too long already, I feel. Then you have your code that changes, functionality of an application, or configuration change. Configuration change might be, my backend. I'm moving away from, Windows Server. I upgraded, or I'm going from RHEL 7 to 8. I'm updating my operating system, or we're gonna use a new database. We're not doing MySQL anymore, but we'd move to MariaDB, for instance, Maria database. So that's configurational changes. And then one that's oft forgotten is data. Your data structure might change, or the way you want to work with data. And I'm going to talk about that in the context of what's going on in the Belgian public sector now. I mean, one of the things that's going on in the Belgian public sector. Your data structure might change. And that needs to sort of translate into a lot of changes in your application architecture and infrastructure. So the steps there are still the same. You're going to build and test. You're going to deploy an environmental change. You're going to deploy a change. So don't think of deployment as some very narrow concept. No, it can be it's deployment of a change, and that change indeed can be in your environment, data, code, configuration. And then you're going to see, are we happy? And then it's back to, if you're happy, hopefully. You don't need to roll back, and you work on your backlog of changes that you need to implement. The two are related through, I would say, and here I would say, ITIL 4. Maybe we should refer these as management practices to make the distinction between these. Project-based activities and permanent functions. You need to manage your deployment pipeline, and I would say also your service deployment pipeline. There are tools for that. I'm going to talk about that. Let me talk about that. Packaging managers in your integrated development environment that are easy to use and everyone should use the same, and you need to do your version release control. And for your deployment pipeline, yeah, exactly to help you with that version and release, you're going to use tools like Argo, continuous development, continuous integration. Release management, we talked configuration pipeline, configuration deployment pipeline, infrastructure as code. And then indeed, this is nice, and I'm going to highlight that. With all these changes, do focus, on the full life cycle of your product, of your service, and think about, things that are necessary, not necessarily get a focus in your agile approach. Is how are you going to set up my help desk and organize first, second, and third line support for something, for the case, if things would go wrong, and if things don't go wrong, you still want to have feedback. Indeed, that request management that you do around the service uses that request specific actions so that they can utilize the service, but that incident and problem management. So he wrote this book on cloud native, Kubernetes, and a few other things, but basically cloud native approaches, agile approaches, microservices. So he said that, and I really like that. That shows realism. Incident response is one of the most important aspects of running. Well, he talks about a Kubernetes deployment, but he basically, his book is about really moving towards a service-oriented, microservices-oriented architecture. A well-defined incident response plan can help you quickly identify and mitigate issues with your Kubernetes deployment. I'm highlighting it really because I will talk a bit about my previous organization, and maybe not always positively, many times negatively, and they didn't get that right. They didn't think about it. They didn't anticipate it, which is sad because you don't get the benefits from moving towards a new architecture, application architecture, if you don't think about these things, because things are complicated, I said. So that brings me to the more classical view. I said this is a slide I made collating some things, but this is sort of what I got from a commercial site. I don't know which one. I can clearly see they have their preferences for certain tools, but it's the DevOps cycle, right? Development, we code things, we're going to plan. Sorry, it's the other way around the circle. We're going to code something, we're going to build it, we're going to test it, we're going to release it, we're going to deploy it and operate it. And then, of course, we monitor it, and then, we do something else. So that's that cycle of, implementing changes. And when the change is implemented, going back and taking the next thing on your list from your backlog. Let me clean up my... So the problem here, I think, as an ICT manager and also as a project manager, is that you need to bring... I said things have not become easier. People together who work with very different tools, who have very different mindsets, and there's a few here. I said it's a bit biased, deploy. Docker is mentioned here, so as a new architecture. But yeah, we have .NET, of course, and all the other stacks, which may be more suitable or which you may be more comfortable with. I said moving to a new deployment environment or restructuring your deployment pipeline is maybe not the best idea. You need to prepare it well. To operate things, I said there's a few tools here, Chef, Ansible, Kubernetes for cluster management. I said I could mention others, Helm, Argo. I worked a bit with Puppet. I like it very much for environment or configuration management. Distinguish like roles and configurations, and then automates the release. You need to think about license management. Make always sure that you have a long-term support version of a software. So yeah, these tools, monitoring, Greylock, honestly, I don't know. Grafana, yeah. Really beautiful dashboards. I installed it, but Grafana works with other tools, listeners or agents, as they are called, on your infrastructure and applications like Prometheus. But again, there in the organization I worked for, we need Grafana, we need Prometheus for cloud Victoria metrics, Ishinga. Ichinga, the old open source tool, is obsolete. I'm not so sure about that. If you can manage Ichinga, I would say you will not be able to sort of do much better with Prometheus and then Grafana on it. Jenkins here in the test environment, they mentioned Azure. Yeah, you can test in the environment. I'm a bit surprised they put Azure here. I would think more of Azure as an integrated development environment, and of course an operational environment. If you are going to move things on clouds, which I recommend, there's some people say, well, with too much stuff, there's always this oscillation between we need to do things on premise or in the cloud. I would say there's a lot of things that go into discussions like that. Maturity of your organization, how much you want to know about your own infrastructure and your own applications. Again, the organization, it was very much a Java-based stack. They did things on premise, but at the same time, about 60% of the people they used in the ICT were very expensive consultants. Well, very expensive consultants are always very expensive. But I was wondering, in the longer run, that costs a lot of money. The ICT budget for that organization, which had only 5,000 employees, was over 100 million. Just as a comparison and as a benchmark, that's the budget of the largest bank in Belgium, 100 million. And the largest bank in Belgium has, I think, 5-6 million customers, or at least accounts to manage. Has 10 or 15 times the number of employees, etc. So you need to start thinking about the bang for the buck there if you see figures and budgets like that, and you sort of compare them to the size and the complexity of what you're managing. And in any case, I'm not going to talk about that, but the tools that are managed here, while GitLab, of course, as repositories. But think about your development environment. You want it to be integrated, and you want to stick to it, if only because even when you work with consultants, you don't want it to be a black box, and you want to be able to. That should be a permanent effort to attract more people, better people, as permanent employees. I'm very honestly saying that I'm a consultant, but should be an objective of organization to replace consultants, phase them out. So yeah, outsourcing is probably necessary, but outsourcing consultants tend to bring in more consultants and firms, consultancy firms you work with, or integrators, they want to do business with you. Let's be honest about that. They want to still be there 1 or 2 years from now, and preferably they want to renew the contract and make it a larger contract. So think about that. Your environment. If you work with a lot of contractors, they will come with their own little tools. Make sure they get integrated into your integrated development studio, and probably you'll have 1 or 2. Based on, because you will have a mixed Windows server, you will have Linux servers. So both in the front and the back end, you'll need to master various stacks. So for instance, Visual Studio for .NET, Eclipse for I said the Java stack. You will have specific tools maybe that you like, that you're comfortable with, like Postman for APIs. I would warmly recommend. I looked at the Google integrated development environment, and I want to do more with it. That's sort of the third one that you really need to have. Fantastic APIs, linking indeed to the things everybody talks about now. Integration of AI, and easier, deployment, multi-platform deployment. The smaller things, code blocks for C++, people like that. It's nice too. It's very specific, and etc. So I talked a lot just to give you an idea of that. Things have become simple. There's a lot of automation, and there's a lot of automation of the automation, but you need to manage it. It's not going to happen by some magic that your CT budgets are going to come down. Maybe they don't need to come down. I think everybody knows that budgets grow, but you need to keep it under control. Your investment costs, the recurrent costs that come with a new investment. I talked about that portfolio management. Look at that. Take total cost of ownership view on a new technology that you're gonna adopt, be it low code or microservices or whatever. To finish and wrap up on this thing, maybe I put a few things here as tools. I saw, and that's a positive thing. The test environment of the organization I worked for now 6 months ago was based on a test rail, and for me as an issue management tool, but you can really use it for change requests from your development teams to your operations department, which need to put stuff and deploy stuff, put things on the data center or deploy them in the cloud. And I saw it working really, really well. So test trail for me, think about these integrations you can do. So you also have, I often say that you have an integrated development environment, but what about your test environment? Is it as integrated? So make sure if you use IDEs like that they line up nicely with your deployment, service deployment, and configuration deployment, because often you'll need a new configuration if you bring something online. And the test trail for me is a tool that is, as I said, this comes from a website that talks about DevOps, but is clearly like promoting its own I would say ecosystem. Its own microservices ecosystem in terms of tools and applications, platforms to watch and to know. And I'm talking really personally in terms of my own career development goals also. Said I've always oscillated a bit between project management, technology, and finance, and now I established my company again. I was a permanent employee. I was an independent consultant about 10 years ago. So I'm moving back into the business of ICT management, and the platforms I really want to get to know are indeed hot on the market. But there's a lot of stuff that is hot on the market. But I say this is really worth looking at. ServiceNow. One of the job interviews I had is about that. I know ITIL, making ITIL work better with ServiceNow. I'm a bit surprised that ServiceNow didn't get much attention in the course I just went through, the certification course. It's great. These tools, like for me and ServiceNow, will give a lot of attention, help you model or implement, or help you implement those functions, permanent IT service management functions. But ServiceNow for me has also an IT asset management component. But ServiceNow, the IT asset management component, is wonderful because it's linked up with things like network discovery. So it's going to help you do something I didn't see in that previous organization. So what's the logical network topology and what's the physical network topology? Because if you talk about cybersecurity, it was another thing they want to do well. If you don't have a good map of your network, then how are you going to do the things you need to do? Better network segregation, and perhaps even network segmentation, really isolating certain sensible your secrets management, perhaps in very specific and more secure domains. I'm going to talk about the term domain and how it relates to networks in a moment. The ServiceNow platform also has really nice integrations with application interfaces, I would say, with indeed Visual Studio, AI tools, low-code platforms. So the integration suite, it's not called like that, of ServiceNow, but it's nice. I also know that ServiceNow is unfortunately not a very cheap platform, but I think it's really worth paying the price, and it has a price per user, per power user, I think. So that makes the pricing model very nice. When SAP moved to HANA, there were a lot of technological innovations there. Allows you to work with, in-memory databases and stuff. It has an integration suite, which is also quite powerful. And of course, you need to, and that's what I want to do a little bit, is continue to get to know, the Microsoft environment with Azure, with the cloud the facilities that are there. But at the same time, for Java, see what's happening with the Oracle Fusion middleware, as complemented by new things you need to do in a heavy duty environment, I would say. So when you have asynchronous communication between your client and your and the server side that you're managing, you'll need tools like Kafka for event queuing, Nifi for data streaming, including event streaming. These are highly technical things, but these are platforms that that are winners, that are there, and that you need to master in a cost-efficient way. Don't leave that to consultants, I would say. Personally, I said this is a bit personal certification that I want to do is, as a manager, and I'm not talking as an ICT person, but I would say any manager, do these very easy certifications. W3 schools, learn how application looks like. Start with scripting languages like JavaScript or PHP. Of course, the base is HTML5. See how an HTML form looks like, what the elements are, and they also, personally, I learned a lot about object orientation from learning HTML5. Domain object model of HTML is a perfect introduction to this new philosophy. Well, new philosophy. I'm an old man. Object-oriented came on stream 20 years ago, but doing these easy certifications, they are cheap, helps you to understand that better. I also mentioned here Microsoft Learn, become a Microsoft engineer, that's my goal. The IBM documentation, I'm not sure if there's a certification scheme with it, but IBM is still great in terms of, if you go through the documentation, you want to know, you want to Google something, Google on the IBM side. For a lot of stuff that will help you. I'm saying that because I did a few expensive certifications, like I paid for the ITIL version 4, €700, I think. For €700, you have full access to W3 schools. That's what I did about a year ago to really update my certified developer certificates in PHP, JavaScript, but also, C++, C, Python. I did a few others on the go, basic cybersecurity certification, data science, working with big data. What is big data? And, that's all nice. And you pay €700 for a year-long access to a lot of nice stuff. The next thing on my list is actually AJAX, as it's called, asynchronous Java, and XML. Okay, that's enough in terms of answering the question. What do you know about tooling around DevOps and ICT management in general? Always keep in mind that indeed that DevOps is, for me, it's nice. It's not a methodology for me. It's often described like one. For me, it's a set of practices, and a set of practices much more than these 34 management practices that you have in ITIL version 4. This is a real core management practice. You need to set up your organizational resources. You need to set them up in a way that takes advantage of all these tools that are there, and make everything work together. Okay, let me now go back to a more romantic or more philosophical discussion, and it's actually the title of the notes I made here: Abstraction and Instantiation, I call it. And it's a bit of a reflection on what has changed, and what you need to know as again, not specifically as an ICT manager, but as a manager in general, who or a business owner. We have business owner, application owners, or product owners. There's been a multiplication of roles, but let's say I think the two most useful roles are, like the business owner, who drives and who requests for new developments, and then the application owner, who over the life cycle of an application with various services inside will ensure that application continues to evolve, improves, and implements changes around it. So both business owners, as I would say, as application owners, to a lesser extent, really what I would call the product owner, the head of development team, that may be different from the application owner. But you need to know that, I said, things have become simpler. There's been a lot of automation of the automation. But I would say, looking back a bit melancholically, object-oriented programming, you need to understand it from, I would say, in a more intuitive way than, abstract away, I would say. That is abstraction. Abstract away from the programming, the object-oriented languages. Don't worry about this philosophical distinction between, this is more like a procedural language and this is more object-oriented. I will talk on the next slide a little bit about object-oriented COBOL. It's going to be a funny discussion. So these distinctions have all blurred, but you need to understand what objects are. And then the other example of abstraction, I would say, that you need to understand is, this virtualization infrastructure as code, where you split environment configuration variables from the applications. So you can indeed use these environment variables and infrastructure, configuration items in a way that allows you to write once, as Java would put it, and deploy everywhere. And avoid what people complain about is write once and debug everywhere. So I want to be specific and talk about how I understand objects and object-oriented programming. I think we live in ICT. I always say, like, okay, an object. We're talking about a programmable object, right? And that helps already a lot in terms of coming to terms with what objects are. They're programmable. An HTML element and an HTML form. That's an example of an object. Well, that needs to be programmed, needs to be structured. You will write code around that object. So, and then it's, of course, just like in the real world, if you think about objects, cars, people, animals, they're going to be part of a class of objects. So, and I think that's where, in the last 20, 30 years, object-oriented had to come on stream. And I'm going to demonstrate in something I'm familiar with, low-code platforms. Low-code platforms have been around forever. And I started in them. I started working with the what was called the Information Engineering Facility, which became Composer, and I think I haven't followed where the product now is. It's probably sort of incorporated in the platforms that you have now, Mendix or OutSystems. But they've been around forever, and I would say 30 years ago things were quite easy. We would indeed model what I talked about just a moment ago, like these permanent business function and processes. So we would have a business process model. We would put that in there, and then we would say, okay, that's the what. What is happening in our organization? And if you want to automate it, you need to see then how. From what to how. How are these things done? And so then you go into the concept of a procedure. Full complete actually in IAF at the time. The permanent business functions were referred to as functions, so the language wasn't ambiguous, and the procedures were called to as processes. What was the difference between a process or a procedure and a business function? Well, it would be a smaller unit, a much smaller unit, and it would, start. It would have a start and stop and then end, and in between a number of activities or sub-processes, if you want to call them, steps, work steps. So there's a bit of a workflow, say process, procedure, workflow. We would use that a bit interchangeably, but the main thing was that a process like that would have some integrity around it. And to give you an intuitive definition of what is the integrity of a business procedure or a workflow or a process, is that well, either the job gets done or it doesn't get done. And so there's a status. Yeah, COBOL, it's sort of like the return function of a program code. An error, it didn't get done, or it got done. So you have an integrity. To give an example with the databases, either database gets updated and gets updated in a way that leaves the database in a status that is okay, or that is not okay. For instance, you'll have a lot of dependencies in your data model. We will talk about that because that's the third thing we would have in these low-code platforms is our data objects. So we would work with objects indeed. Logic works with objects, but these would be data objects. But yeah, the easiest thing is, of course, you think of a create, read, update, delete actions on records. But let's say a manager has several employees. Or a department has several employees. Let's do it like that. A department has several employees. We abolish the department. The employees need to move somewhere. They need to be assigned to, I don't know, a pool of resources that are available for other departments, or they need to move to other departments directly. So the integrity of this thing, abolish a department, requires that you do something with all the employees that belong to the department. So that's I would say, a data dependency that needs to be respected. So that's where I talk about integrity, and we would talk about business rules that need to be respected and all these kind of things. And it was fairly easy because indeed we sort of, with that local platform, we could build in those business rules. But we basically would have that, procedures and business rules that apply to data objects, entities, that's what we call them. So we would have an entity relationship diagram, data objects with the relations in between them. You've seen that, and that would translate into, a physical database with records. And the records were, this is what we're going to talk a bit about, instances of entities. So that's where I chose the title of my talk. I was thinking, okay, I need to talk about abstraction, what has been going on in that field for the last 20, 30 years. What is the opposite? So I chose instantiation because, 30 years ago, we would instantiate objects, data objects, and that would be the specific manifestation of these logical concepts. I'm rambling, I know, but it's not an issue. I'm not going to promote this video too much. Let me clean up my notebook. So that's when we realized also, when you want to do a better job at automating real life business functions and processes. Yeah, that idea of an object with to which we apply indeed logic, but also business rules that define the integrity of a process. Then we quickly saw that real life objects, they usually do come with inbuilt logic. That's that business rule, and if you can sort of use a higher or more abstract programming language to deal with that, that's going to make it easier to build applications. So that's where James Martin came indeed with this, what he then called the fourth generation language, right? Like other concepts, I don't think that's a very useful concept, but it does give an idea of how much a language abstracts away from I would say the machine language, right? Because in the end, it's all about files being parsed, being compiled or interpreted on in zeros and one instructions and registers. This is where I think we all realize that we should have a more generic object model, which acknowledges that objects are not only data objects, where we have a larger definition of objects, where we say like, okay, objects, basically any object has a data structure, which is referred to generally as it has a number of attributes, which at the time, again, 30 years ago, just translated to, a field in a record, but now that's a bit more complicated. Attributes do not necessarily correspond to fields in a database, because we have far more flexible data management tools, I would say now. Think about XML forms or XML schemas, data interchange protocols. And then the second thing is that objects, they do have inbuilt logic that you can tap and to execute a certain action or request that ensures that you will come out of the once the process is executed with data that has integrity, and your service or your application component will have a state that is okay as well. I will talk a little bit about that more, because then we're talking about messages and representational state transfer. But so in the beginning it was easy, and you need to understand a continuum of where things come from. Beginning we had like database on which you could store procedures, and besides the simple create, read, update, you could use stored procedures to help you execute those business rules that are associated with a certain business process. Okay, what happened then, I think, is that I put that here, from this sort of logical evolution in programming. We had this phenomenon. CPUs, and we'll not only say CPUs, but also like graphical processing units, became enormously powerful and affordable. My programming, I worked with a Commodore 64, which was the NEC Plus Ultra. I mean, it was affordable. There was Steve Jobs that came with Next workstations, but these cost like 10 times the price of a Commodore 64. But we had 64 kilobytes of internal memory of RAM. Now we have 1632 gigabyte, 16 standard on a laptop, giga, factor 1,000. So we all know what happened. That made for distributed computing, these devices that we use now. Instead of a dumb client, everybody works on a laptop now. We also have lighter clients, but still a lighter client, who works on, the Google operating system, on Microsoft Surface, lightweight systems that are built to, implement that client-server architecture. It's become cost-effective, efficient, and user-friendly. So we moved a lot of the logic to the client side. So together with that, when you have distributed computing, you move indeed to that idea of a service-oriented architecture, as opposed, because can mean anything. Let me clearly say what it is not, as opposed to a monolithic architecture. And I think the example that we still have, and is still functional in certain aspects, is like indeed that mainframe terminal, dumb terminal relationship. We'll talk about COBOL in a moment. For some applications, that is still a valid model. So I would say service-oriented architecture, but yeah, just doing microservices because you want to do microservices. Yes, maybe, but make sure that you know what you're doing and why you are doing it. So with the service-oriented architecture came, I think, what I call new abstractions. We started talking about domains and domain object models. Objects that would be specific to a domain. And I mentioned here one, the HTML domain object model is an example of that. But we also have, domains in, identity and access management, which has come a long way from, the user has a password, so he has access to all of our infrastructure. Now it's a much more subtle than that. We have resource domains, various types of domains in identity access management. Users can be grouped in very different groups. I will talk about a bit that in a moment, etc., etc. So that the idea of domains is a very important one, and I think that's also one that you don't need to be a technical guy to understand why this concept is useful, and to sort of make sense of what what your ICT department is doing, and why things are simple and again complicated at the same time. So domains, you will know it from domain name service, DHCP service, this and that. One thing, often ICT people, they like you to sort of, the namespace. They come with these newer terms. A namespace is closely associated with a domain. For me, a namespace is something, it pops up in an OpenShift deployment, cluster or subcluster, you will have a namespace. A namespace really is a very simple concept. It allows you to name things within a certain domain and an identifying name. Think of a family. The family would be the domain. My name is Van Bella, and so I have a lot of brothers and sisters, and they're all called Jean, so second name is needed. Jean-Pierre, Jean-Marie, Jean-Louis. But then with that second name, you can uniquely identify Jean-Louis within the larger Van Bella family. As a resource, as a user, or as whatever, or yeah. Okay, with objects came then, if you move away from data objects only, but you think about, services or modules or applications, came the idea of, okay, these communicate with each other, but we had this, the simplest model was a HTML request and response, in real time. A client will transfer a request for data or for some code to be executed, and that will be done. And then it goes back to the client, said, okay, your operation succeeded. You've successfully submitted a form, or else there would be an error. We did not manage to process your request. So that was the SOAP model. That's our single object access protocol. One object communicating with another through some kind of message, but in real time, synchronous communication. And that's where the idea of REST came up, where instead of real-time HTTP requests and responses, we might have asynchronous communication. I think I gave the example in a previous presentation, might repeat it. For instance, a user wants to do a bank transfer between his accounts or to another account. That will go as a message to the bank. Please transfer that much money from this account to that account, etc. For the user, that request should be a REST request. He transfers a message. He sends a message, and then the message needs to get processed. But we disconnect the processing of it from the requirement to respond in real time. And that's where these message queues come in, and it reminds one a little bit of of batch jobs really at the time, where dumb terminals would add requests to a long backlog, and that backlog would be processed in a job at night. So that's nothing new. It's just that in this new architecture now, well, things work a bit differently. There's a lot more protocols. There's a lot more types of messages that can be exchanged, etc. And also, yeah, events. A very simple example of events. We have these HTML objects, elements. It could be a form or an input field or whatever is relevant and requires some input. We want to put logic on the browser that can already if it's simple request for some information or some more detail on what kind of input is expected. When he hovers over a field, that will be an event, and we can have an event listener, and the event listener will alert, hey, the user wants this, the user wants that, and we can already use the event listener. Will say, okay, that's something that we need to process. That's an event that's relevant for an application program, or execute a script on the browser itself. Again, I like the thing of HTML objects because it's the clearest example when you have to explain what object-oriented is an HTML object. If you go through the form, the elements will have properties or attributes, as said. And that's not necessarily what I said here. That doesn't make you think of a field in a record. No, that's just a property attribute, part of a data structure of an HTML object. It will have methods associated with it. Simple starting get some data, or post, which is a safer way of asking the server side to do something. And then HTML objects are associated with events. On click, do this. On hover, on mouse, do that. So I will keep it at that. But that's sort of, I think, when you understand these concepts of domains, messages, objects, events, event management. And remember that when you understand these in an intuitive way, but remember they all go back to the same thing. Like when you talk about REST, it's about integrity of components in a larger system. It's about subsystems in a larger systems, and unfortunately, or fortunately, that has moved a lot away from what we used to do 30 years ago. Is okay, this is my data model. This is my process model. And now, I'm going to use an engine to build me an application for the mainframe on DB2. Okay, I've been talking for a long time, but I kind of enjoy it. I want to say one thing on programming languages, also from my experience, and this is where I'm really going to be a bit nostalgic. COBOL. And legacy, right? First, legacy. Think positively about your legacy systems. Treat them well. One of the guiding principles in ITIL 3 and ITIL 4 is start where you are. If you have an CIO who sort of thinks like, well, this legacy, we need to get rid of it, then I think you're making a very big mistake. It's a huge investment. And I said even the best of ICT organizations, and I'm thinking of banks here. Belgian banks, I admire them greatly. In terms of the apps you have on your phone, the security of their systems. They build actually authentication apps like, it's me. If you're in Belgium, you will remember. is beautiful. It integrates biometrics, multi-factor authentication in a way that no other organization could have developed, and they do it within large ICT budget. But I said the one statistic that really struck me is KBC's budget is about 100 million euro for per annum. That's a lot, you will say, but it's not a lot if you compare it to the organization which also had 100 million euro budget, and most of that would go in new investment. Well, we're going to do low code. We're going to move towards a microservices-oriented architecture, and they did that. But without thinking, without refactoring their applications, without really going through the business case, identifying the critical success factors that are mentioned in that business case. Well, if you want to reap the benefits, without doing any reasonable analysis of alternatives. Do we have a performance problem? Perhaps not. If we have one, maybe it can be solved by, indeed, application refactoring. The applications that were built in the organization were all running in their own silo. Each application, micro application, I would say, each service had its own web server, had its own application server, and so there you arrived at a stunning figure of more than 4,500 virtual machines running on, maybe 10 racks, less, 200 physical machines, 200 physical servers spread over 2 data centers. So actually 100, because the other data center was supposed to serve as a backup or failover, but no consideration whatsoever for, are we really tier 2? Are we even tier? Are we tier 2? Are we tier 3? Do we want to move towards tier 3 availability? I think they were tier 1, which is the worst. You might as well just have one data center and not bother about backing up in another one. But to go back to COBOL here, that's what you will see if you go on Wikipedia. Which sort of, I wouldn't say it makes fun, but it sort of tries to highlight how complicated things were 30 years ago. So yes, this was how programming looked back in 1978. And I would say my first job was with Accenture. We were sent to Chicago on the Q Center. And we all had to learn COBOL, and it looked pretty much the same. It wasn't free format at the time. We had these punch card like editors, 80 columns, and you really needed to watch out where you put your character. And just to give an example, you might think, okay, I've got a slash here, so these are all comments, no, they're not. If you put a slash in position 1, then it's not a comment. If you put a slash here, then it's the same as putting your asterisk. Then it's a comment. So this is this is code. Base test runs something, executes on a machine. We have this cop system in data definition. With no extra parameters, we have this thing. This is all code. This is preparation code. I said the validation of basically the installation of the COBOL. And I said this is written in 1978, but it's actually an emulation of a guy. I'm gonna call J Mosley. I looked at his site. It's beautiful. How he plays still with COBOL and how he admires language. And I sympathize with that because, first to finish in that. He does emulation, so his workstation is a GNU Linux system, and the object computer is Hercules, which is basically an emulator of a very old system, 370 mainframe with operating system MVS. I don't know, is it multiple virtual system or something? In any case, people were talking about virtualization already then, but so he emulates that, and so don't worry too much about that. Just remember this is code that you need to specify. But then we would have that an identification division where we say, okay, this program has this name, and environment is the division which is empty because it's efficient. These things and these things have all the configuration and environment variables that we need. Special name console. I don't know why he put that there, just to show that you can have your own specific shorthands for longer terms. That was something nice about COBOL. And then we need to look at here. This is actually the logic, the COBOL logic. Display hello world upon the console, and then stop run. I mean, and I don't want to criticize the author of the Wikipedia of that section. Like, oh, COBOL is complicated, is verbose, is honestly, how much simpler can it be? Display hello world on the console and stop your run, and then wrap up the program, see what happens, return errors or warnings or whatever you want to return on the console. And that's also how COBOL looks now. If you download now OpenCOBOL IDE from the GNU repository, you can run this program with just an identification division that needs to be there with the program ID, the name of the program, and then we have the procedure division which says display hello world, and it will run, it will work. So the libraries that you have and that you need to have that you will have with other programs, if it's Java or Python or Go, new modern COBOL is not very different. This is actually from the GNU COBOL site. I looked at the manual. Notable COBOL, GNU COBOL features, and it starts with basic program readability, and so that's a bit the opposite of the Wikipedia, who says, this is crap. He says the most vociferous critics of COBOL always focus on the wordiness of the language, indeed, often citing the case of an infamous Hello World program, this one. It's famous by J. Moseley, who didn't intend, I think, his program simulation of COBOL in 1978 before COBOL 2002 came on stream, and object-oriented COBOL, as a proof that COBOL is so much more tedious to program than modern languages. This tedium is cited as a significant impact to programmer productivity, and they believe that COBOL cannot go away quickly enough for them. I said, if you there's examples, you can Google that, but if you're going to take money from an ATM, in 95% of the cases, the whole chain of things that happen when you put in your code and then money comes out and you withdraw your card and you walk away, is that in 95% of the cases, some COBOL code is still going to be executed on some mainframe zooming, and it's gonna, these mainframes zoom very reliably, and they have all the features of a tier 4 data center built into one powerful machine, and we call it a mainframe, and we think it's bad. Well, you can do hot plug-in of hard disks, you can change equipment, reliability, safety is great, and that's why COBOL is still around. In terms of wordiness, I'm a certified developer in Java. I don't like Java. It's a very abstract language, and indeed, but look how a Hello World program class. We need to define a class. The class is going to be what kind of class? Well, yeah, that's basically your application, your source code file. It needs to have the same name, .java, hello world.java. So that class is an ambiguous concept already. It's code, it's your file name, it's a lot of stuff. Doesn't make it very clear for me. And then we have an entry point for the program. Like here we have the procedure division, so we know where to start. That's going to be public static void main strings arguments, all empty. Public is, well, it needs to be accessible throughout the environment, I would say, the system. So it's like the domain. Domain is going to be in the public domain within that namespace, I would say. Static, void. I forgot a bit what static is as a qualifier. Void means there is no return function, which is kind of funny because you do want to return has this program worked or not worked, but no, there's no return from the main function or logic. Let me clean up again. And then you may be go sys print data definition statement, sys out is A. A is here somewhere. Any case, that's sort of, I don't remember where that data definition language came from, and I can't explain it in detail, as you can clearly see. But I do know that these things don't look that much different from, I'm gonna have a system library that's gonna have some functions or methods that are grouped in a sub library or a subdirectory out, and there I'm gonna have a print line that I can call, and that's gonna print the line to the console, and that line is gonna be hello world. Where I said, in COBOL we have identification division. This program is named hello world, and you're gonna display hello world. It's shorter than your Java implementation. So I've been rambling a lot, but I hope this makes people like me who are getting a bit older feel not too bad about what I did, and gives them indeed a bit of a feel for how we should be thinking now. The environment has become more complicated, but at the same time, ICT isn't rocket science. It has never been, and I don't think it will become a rocket science. In terms of a fast deployment, I want to show you something, and microservices. Here at home, because I had time on my hands, this doesn't lead to a certification, unfortunately. But yeah, people would ask, what do you know about microservices? I really warmly recommend, I talked about him, Mauricio Salatino. I think he's based in London. He wrote, I think, a second book now, Continuous Delivery, right? That's the buzzword of continuous delivery. We don't go for quarterly releases as part of, a waterfall approach with, big chunks of work that need to be defined. It had its advantages, but, if you want to move away from it, do read this book, Continuous Delivery for Kubernetes, but actually the book is surprisingly more about cloud native, an approach, a philosophy, rather than Kubernetes. Yeah, so let me very quickly say what I did. There's a bit of noise in the background. My wife is cooking. I did this actually. I had a home setup, and I thought like, okay, let me see what this thing can do. So instead of, this book is sort of written for Unix developers who are active, who are working in ICTs, and I said, look, I've got a home router, a Huawei, which costs like $80, but that actually is a DHCP server, a web server, I would know, or at least the hardware behind the web server. So that can, I can set up a home network between, I had an old Windows 10 computer lying around with a very basic setup. This computer cost, it's from 2015, 10 years ago. 8 gigabyte RAM, only, at the time it was very performant. 128 gigabyte solid state device storage, so hard disk, solid state hard disk. That was a lot at the time. Unfortunately, that the processor had 8 gig RAM. That's a computer which now costs about 300 euro. That's it. So I wanted to know, can I use that as a client, or conversely, I could switch roles. A server for my other computer, which is like I would say my workstation. It's a Dell Edge, Dell Envy. That's not the Edge. Dell Envy laptop, really nice. Nice because it's got touchscreen and 17-inch, but also nice in terms of a Core i7, quad core. processor with a terabyte of sorry store. That's kind of neat. That approaches the capabilities of your low-end industrial service like a Dell PowerEdge R730. I'm gonna talk about a service a while. Then that could surely serve as a server. So communicating through the internet using my Huawei router. Well, Huawei, I should say. Huawei has been very unlucky, as we all know. A lot of organizations want to replace their Huawei routers because of unproven charges against. Well, I'm not going to go into that. I think it's a lot of nonsense. Cisco has had a a huge security breach 2 years ago. So replacing Cisco routers, Huawei routers by Cisco routers is going to make us safer. I don't know. Any case, that's not the discussion here. I set it up, a client server with an application which is indeed nicely factored. A conference organizing, an application for conference organizers, a company that specializes in the organization of conferences and events with a front end, cloud conference. 2025, where one was programmed with an agenda system for these conferences. On this day, that conference is going to happen. What is the agenda? Who is going to speak? Sometimes things need to be rescheduled. I mean, a lot of functionality there. Call for proposals. So you will have people visiting that. I want to go to this conference. And or users that say like, well, I really want to present something at that conference. So here's my paper. And so there's a lot of stuff there that you need to manage. The conference organizer log on as sort of administrators. And then there's an emailing system, you update people. Conference is full, no more subscriptions or more subscriptions or confirmations, registrations, etc., etc. And the email also with the people who, the presenters. So this application had an in-memory database, and during the conference, there's going to be a lot of requests. I want to go to that room for that conference and whatever. So there you wanted a powerful in-memory database like Redis, and then for the other stuff, more permanent storage on a hard disk using PostgreSQL. So a fully fledged, web application. And yes, I built it as he promised in this book. You can build this thing in one day with one command. I'm not going to go into the detail of how that happens, but just sort of practically say, because I want to talk about virtualization and other things. These are all the commands that are behind that thing, but I wanted to show what. No, I don't have it here. Any case, the thing you needed to, yeah, okay, it's here actually. It's on the same thing. A practical example, what you need to do is, Docker Desktop is free. I said these were 2 Windows PCs, and I was in touch with the guy. I said it's kind of nice what you did. A very untypical proof of concept of his design. But yeah, on Windows, so I have 2 Windows laptops. I installed Docker Desktop for Windows on them. It requires the Windows subsystem for Linux on Windows, which works as a charm. Both on that old CPU, as well as, of course, on Mauricio. Both have, and this is essential, virtualization technology. I'm not going to go into the detail on that, but yeah, it allows this machine, as cheap as it is now, allows you to run a virtual Linux machine on your Windows laptop. And so you need to install Docker desktops, but Docker desktop, but you need to enable virtualization. In the BIOS, which is not standard, but you can do that, and you go into the BIOS virtualization technology, and you install Windows substitutes to Linux 2, which is a fully fledged Linux kernel. I can talk about the difference between WSL 1 and 2, but I won't do that because that will get me into the weeds. But so Docker Engine does run its containers on a Linux virtual machine on a home desktop. You can do Windows containers as well, but that requires Windows Server operating system. You can actually do it on a pro version of Windows 10 and 11 as well, but I don't have that. I have a home version. The second thing you're going to do is Kubernetes in Docker, also a laptop or a workstation. So you install that. You use PowerShell, and the nice thing about it is the easiest thing is actually to use a Go. Go. So I had a command line interface for Go, which runs in PowerShell. Beautiful how these command line interfaces now work together. So Go install this. Get that resource, kindat version 20 of on this side on GitHub, because Go works with GitHub. So I did the installation. Well, I would say initially it failed because my internet connection was bad. I had a TLS handshake timeout just to say what kind of problems you might run into. But I was the only one. And then, Kubernetes indeed is like a known application for which you can, with its own commands, you can do create a cluster. And that will be the cluster on which Docker desktop will running. It's kind of a nice thing of, I wouldn't call it bootstrapping, but things that run on things that the Kubernetes has a tool on the desktop, kubectl, which you also need to download and install. And then the last thing you need to install was Helm as a package manager, because that allows you to indeed promise to what Mauricio said, with one install command, you'll install this whole thing. And that's true. But that requires a packaging manager and YAML files, configuration files, within nested configuration files, YAML files. And installing Helm was a bit more of an effort, but I used a Windows packaging manager. It was kind of nice. A packaging manager to install a packaging manager, Shoko. Really nice, because frankly I ran into some problems, probably because Helm, you want to use it on Linux machines, and I was running this Windows thing. So Helm is so I did a Kubernetes Docker deployment on two Windows, well, on one Windows machine, who then worked as a server to another one through my home internet. Extras I did was Docker integrates really well with Prometheus. As a monitoring, Docker has its own, it will show you the containers that run, CPU usage, memory usage, but you can do more sophisticated stuff. You can freely download, a Prometheus agent that, is going to sit on your Docker, and then you can do dashboarding using the cloud tool like Grafana. All in one day? Yes, all in one day. So the nice thing about this book is that it sort of guides you through what you could do if you want to develop this application, I would say, a bit more manually, and I'm going to go in that too. But this is the command, really. With Helm, install an application called Conference and use this chart. I'm going to explain what a chart is in a moment. And it works as a breeze. It installs this whole application, all of these services that communicate well with each other, Redis, PostgreSQL, the three backend containers, as I will call them, and it runs them nicely together with the front end, the web server. It downloads all what you need, the CSS files that come with it using Spring Boot, and a lot of other frameworks with just this one single command. Helm install and then you refer to what is called a chart, and I'm going to talk about that now in more detail. To do that, yeah, I'm going to come back to this, but let me maybe start with this Windows subsystem for Linux. I tested it. Again, when you Google this, people are going to complain like, "Oh, well, performance." What is WSL2 Windows subsystem? It really installs a full Linux kernel. It is a complete virtual machine. It doesn't emulate. It is a Linux kernel, and this is why it boots really fast. I'll use that also. Small resource for friend. I can't judge that really. It does not run with current versions of VMware and VirtualBox. Why not? Because, well, it uses its own virtualization architecture, Hyper-V as it's called. Oracle VisualBox and VMware Workstation are basically, a different type of hypervisor. Yeah, here I need to talk about hypervisors. I'm not going to go into the detail, but something like VMware, ESCI is, a hypervisor that works on your hardware and then serves you an operating system on which various applications are gonna run. Yeah, Hyper-V is an alternative. It will have your hardware, a Windows operation system, and a Linux operation system, and that's sort of hypervisor gone, and you're gonna have apps running on Windows, and you're gonna have apps running on Linux. I'm going a bit fast here, but that's why it's not compatible. What are you complaining about? You get the real thing. So it's a real VM, full Linux kernel. Performance, of course, that's something if you go, WSL2, performance across OS file systems went down. Yeah, because it's using the Linux file system. It's no longer, just bits and parts of a Linux kernel that are implemented or emulated. No, it's a full Linux kernel, and it's gonna call the file system management system that comes with a Linux kernel. And so yes, there's a bit of understanding that is needed there. It's still a hybrid setup, but it's a full hybrid setup. Well, it's not so hybrid. It's two virtual machines running on your thing. So what's Docker then? I said WS2 enables Docker and then Kubernetes. So yes, it enables containerization. We can run Linux containers in a Docker installed on a Windows server, and it's gonna enable these microservices and the use of Q8s. Docker, over 70 plus of Fortune 100 companies are using it. Are they fully implementing it? Well, that's a different question. I will talk about it in a moment. Let me first explain what it is. So what is Docker? What are containers? How do they work? What are the benefits? We're talking indeed about a hybrid model. You can't really classify it as type 1 or type 2 hypervisor. I will talk about that. It's got aspects of both a little bit. It's a new way of virtualizing things. And how does it? It's we have containers which are like independent, call it REST services, accessing kernel services. And yeah, I said here it only works on a Linux kernel. Well, you can host on Windows, but in setup I had. So the containers are hosted on a Docker engine, and often it's kind of a bit difficult to see what Docker engine does and what Kubernetes does. And I hope these figures. Yeah, I need to sort of wrap up a little bit. But Kubernetes is really, we're going to have these services, as said, which I showed. I know application components. Let's say they're going to be packaged into, one or more containers, or vice versa. One container is going to pack one or more services. The application then consists of containers interacting with each other, and we have Kubernetes around it, and the users are going to interact through Kubernetes and Docker, but they're not going to see the outside. What Kubernetes does is basically it organizes and gives access to all these containers in what is called nodes that are organized in a cluster, and that is gonna then do what is here. Kubernetes is gonna say, well, okay, container B and worker node 3 is going to use machine 2, which has 2 CPUs, I would say, RAM. I mean, this is really to show that these are real or virtual machines. They could be, but they have a certain capacity, and they're CPUs that run a Linux kernel. And this container are going to use a machine, and it's going to dynamically assign resources through this process to make sure that the application is performing well. And I screwed up a little bit my notebook, but it doesn't matter. I'm not going to reuse it probably. So I said we have this one powerful command. Let me explain that. Helm. Helm package manager, which refers to a chart. Let me now explain what a chart is and what the other thing, the nice thing about this a course or book is it also takes you to the manual process where you're gonna use create a cluster, and we're gonna create a cluster first for the Docker on Docker, and the name of our cluster is going to be development, and we already going to configure it. This is the thing. We have a config.yaml file. This is how this is where I want to talk about infrastructure as code. So you do that, and you need to do a few other manual steps. I said services need to communicate to each other, and that requires routing traffic between your various services. So you also need to install what is called as an ingress controller. Ingress is a standard. It uses Nginx, which is an open traffic manager, I would say. I'm not a specialist in these things, but that's going to sort of manage, the internal IP addresses and logical ports, so through which these services communicate, and that will assign it to the nodes, which coincide with containers in this example. So it's gonna really, it's sort of like an API running in the Kubernetes control plane node. So that's 2 steps. We create a cluster, we apply a certain configuration, which gets downloaded, so you don't need to bother about that. And we need to install an ingress controller. So what's in the configuration YAML file? All the things you don't need to bother about. Well, that's where that's where he shows that you can build an application in one day or in a few hours even. The hard work is specifying the environment variables. Environment variables will change. If you go from unit testing, integration, staging, production, we don't do much testing here. We play with the application. The ingress routing standard or scheme. And then there's configuration objects that are related to, I would say secrets management. Let's be general. But tokens, users, roles that make sure that you can use this application in a safe way, because this is an application that applies full encryption standards and other stuff. So that's the hard part, and I could open the YAML file. I'm not going to do that, but that's sort of the interesting thing about a YAML file is I thought I'm going to get like an incredibly long, extensive technical document, but it's not. The nice thing is this YAML file applies this idea. It's sort of, you're going to have a lot of configuration files, like you need one for your development environment, right? Because that's going to connect to a development database, and you need one for your test environment where you're going to have a test database, and you need one for your production environment because that's going to connect to your production database, etc., etc. And so you quickly end up, as Salaboy says, I think managing a lot of YAML files, a lot of configuration files, and so you want to automate that process and as much as possible. Well, and that's where Helm as a packaging manager is also a templating engine, and the idea is this: if we sort of know that a certain service needs a configuration file, let's parameterize a number of configuration parameters like that database. We just put a reference to another data object, I would say, the URL of the database, and then the templating engine is going to combine this template, I would say, the service configuration template, which is in a service.yaml file, with the specifics that are related to my development environment and test, and these files are going to have I would say the deltas, what differs between the development and the test environment. All the rest can say the same, so we could have a more general config file, but that should be in the service.yaml file. And your templating engine is going to combine these and come up then with the two files you need to deploy that application in a development environment. So we're going to have a service YAML file for the development environment, which is used there, generated, updated there, to when we do a deployment towards the development. And that service is going to indeed say, okay, the database URL is that development database port or endpoint. For when we deploy to test, we generate another service.yaml configuration file, which is going to have the right database URL endpoint. So, but all that thing, that needs to be set up and managed, and that's what's meant by managing your configuration deployment database. And so, there's more tools than that. I mean, I'm just showing one. But we have a lot of these templating engines that you can use for different frameworks. Here we're talking the application. I mentioned a few here: Helm for containers, and a more classical Java. Your developers will know what Maven is and Gradle. NPM for Node.js. I don't know, advanced packaging tool for Debian. I just Googled a few because there's a lot of stuff around, but there again, it's make sure that you have an integrated development environment that is fit for purpose and fit for use. So you can see things do get complicated and get simple at the same time. There's just a lot of stuff under the hood of this thing, and that's what underestimated. That's also the same thing where, we're going to do low code. There's a lot of stuff under the hood that you need to manage, and you can't sort of wish it away. I'm not going to go in too much detail here, but a chart. What's a chart? So a chart is going to have, in the end, you're going to end up with, files that are generated through your templating engine and that are, configuration files. Here it's okay. We have a general, I would say, generic scheme for our service configuration file. We have specific parameters that relate to deployment, the way we're going to do the routing and whatever, and we send them through a package manager, and then we're going to have a collection of files, which we refer to as a package. That package is going to be used for a deployment, a specific deployment into a test, an integration, a business acceptance test, or a production environment. So we will want to keep track of it using classical version numbering, major release, minor release. If things don't work very well, maybe a new version we need to release to do patching. So a lot of files with a lot of dependencies and not a lot of other metadata. Dependency metadata will include, a specification of the dependencies, description, what is the thing, and then we distribute the package. Okay. We distribute it using a repository, could be GitHub, private GitHub repository on the cloud, or one in our own environment. So again, we have a package, which is a collection of files. Think of what you would have in the old days, library files, and then your own programming logic, etc., etc. My wife is calling me to stop and come eat, so I'll do that in a moment. Let me clean up here. And yeah, they're going to be laid out in a directory tree if we have a collection of files, and that's what a chart is. It is this collection of files which relate to a specific deployment that we want to do, laid out in a directory tree, and we're going to use that chart as said in this command, and then boom, the application is live. Helm, install, the release, conference 1.0.0, the chart name, which also will have the same version number, preferably. Chart name and version are related, plus some other labels, and boom. To show you how this directory looks like, I copied it here. It will have a chart YAML file, which basically has the name of the chart, version, and a number of other information that is useful. The license, which is an Apache 2.0 license, a README file with some explanations, and then here that's the real stuff. The templates. So this deployment template, the services template, that in turn refer to where can I get the infrastructure as code, the parameters that apply to this or that environment. Deployment environment, as said, can be one or more, unit test, integration, acceptance, business. I don't know how many development environments and testing environments you have, or production environment. You could have a backup production environment, so you can have a lot of environments, and yeah, you're going to have a general file that refers to other configuration files that are specific for your environment. So these are the Kubernetes YAML files that are really required to deploy, and specifies how you're going to put them together. Values, the values for the specific environment, the parameters, because here we're going to have only default parameters, and here this is the delta, I would say, between the different deployments. This is a gitignore file, which I didn't understand, but apparently that's a JIT particularity which says which files should be ignored. For instance, specific binaries that are already there, vendor directories, etc. So we have a parameterized deployment. And what is parameterized is the application configuration, and that happens according to the environment, of course, the release, the version, etc. So that's what's meant by infrastructure as code. Let me wrap up because I want to do my breakfast. There's a lot of aspects to look at. I'm not going to go into these things. There's also the concept of pods, resilience. We can have multiple pods running in case one breaks down. They provide, I would say, backup or failover version, which is really nice. These containers sort of repair themselves. There's no downtime if you install it well. The scaling up or down, indeed, of infrastructure, security and identity management. We didn't talk about that. Data consistency, how it's indeed assured through representational state transfer protocols and application interfaces, messages from and to services, event streaming, etc., etc. Just one thing though, on it's not because I'm not talking about these things that they're not important. Dealing with users and security is almost always an afterthought. That's what this guru writes. For distributed applications, these aspects should be clearly documented and implemented early on. Who can do what and when? It's the eternal question, and I'm going to talk about that probably in a second presentation. What I just want to show here is indeed we have our cluster. I say we do not always want to do like a new deployment when something changes. Well, that's the thing about automation, the automation, and Kubernetes. We can update, just the front end, or update one of the services, and you do that because, your automated service deployment pipeline will rely on, versioning and control of your source code, new versions of containers that you have, your Helm repository, and you can access these and dynamically, just change one. So you can organize, I would say, version control of front end 0.4.10, different version number for your agenda service, etc. So that's very powerful, and that's sort of when you talk about continuous integration and continuous release. I said here we talked about infrastructure code. That's what makes continuous integration and release work. Every week we can have a moment where we do an update from hopefully something that is modified to address known errors or workarounds or problems that are just plainly solved or new functionality, and so on and so on. So that's really it. How not to do a migration to, I'm mentioning here OpenShift as an example, because a lot of what I talked about is basically OpenShift architecture. You know what OpenShift is, Red Hat Linux, Red Hat Kubernetes, I would say. It's a licensed version of this open source architecture that I've been talking about. But it's important to, when you, and I'm going to talk about this. Basically, I said containers on pods. It's a hybrid version. In a way, I think you might say that, okay, we have hardware on the client and the service side. Well, on the service side, we run an operating system on it, Windows or Linux, and our hypervisor is actually the Docker engine, which is going to run container A, B, C, and then container A, B, C, or service A, B, C make up component X or Y from, I was going to make up a service, and services are going to, combine to make an application. Service B might be used by application Y and might be used by application A. So that's the other thing you need to watch, dependencies and stuff. It's not easy. There's a lot of moving parts, but yes, it is simpler in a way. It is the automation of the automation based on a deeper, I would say, systems understanding of what deployments really are and what programs really are. I often joke about, in the end, a program, what is it? It's a collection of files. And how many files you're going to have and how you organize them and what's in those files, and how you work with abstracting away from environment parameters that's going to determine if your deployment environment is indeed sort of using the infrastructure as code principle in a way that works. But so I came from this organization where they basically just repackaged the Java applications, which were running on an incredibly complicated virtualization architecture, combining VMware, ASCII, Citrix. They had it all. Basically, because these things were not being built according to a very detailed template or format or architecture, and so the evolution was just evolution. Dinosaur applications that are running in their own silos and that are very, 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 very hard to make them evolve. I mean, just the upgrade from RHEL 7 to RHEL 8 was an update with more than 4,000 virtual machines running in, I looked at Puppet, 700 different rules, a few hundred configurations. Even if you do an in-place replacement of an operating system, you need to find the application owner, and the application owner is often gone, and then you're dealing with a black box, etc. So virtualization like this going to OpenShift is not going to solve your problem if you don't refactor applications, if you don't seize the opportunity to redefine application ownership, business ownership, if you don't restructure your service and configuration deployment pipelines. What they did in that organization is, well, here's the application, we're going to send it to offshore through our contractor, which was Atos, and then it comes back indeed as a chart, a bunch of files, and then boom, we press it and it gets deployed. Well, yeah, okay, you've moved your applications to a new architecture and infrastructure, and so what? Is it going to be more performing? Is it going to address? Is it going to phase out? Lead to less virtual machines? No, no, not at all, because you don't change anything in essence. You just do sort of a bit of, wouldn't say makeup, because it's fundamental, but you don't repackage stuff fundamentally. Take it as an opportunity to review and overhaul your identity and access management. So again, that's what I'm on. Think fit for purpose, fit for use, use proper tooling, revise your key procedures, and then you're going to reap the benefits of it, and that's not easy. So if you're merely repacking or repackaging your existing application as containers, and you're not willing to restructure your current architecture, virtualization architecture, then your whole migration is going to be a waste. Maybe it's going to work, but it will have cost a lot of money, and it will have brought no tangible benefits. So your return on investment is zero. Zero divided by something is zero. Yeah, because the whole idea of moving to containers is ensuring faster deployment by a reuse of building blocks, but then you need to know these building blocks can't be a black box of building blocks. Facilitate maintenance configuration management. They said that idea of really implementing an infrastructure as code. Deployment pipeline, save on hardware by a more rational use of resources, supported by monitoring and better. On hardware, I always think this is sort of the least tangible benefit. This is something I made. Remember, a web server is essentially a program which handles client connections, so it doesn't need a lot of hardware. It serves web pages to the client's browser, passes requests. I said my simple $80 home setup thing can handle 32 connections, so that's 32 times 2, 64 devices. Well, okay, it's from a port to a port. So you €70 home router, your enterprise grade gateways, routers, etc., and the software that runs on it are probably able to handle 100,000 or let's say 50,000 connections simultaneously. Why? Because usually there's not so much requests and responses that need to pass through connection. A connection is open. After a while, you need to close it. There was a problem with a organization I worked with, but yeah, you can keep open a lot of concurrent connections, and so you don't need a lot of hardware for that. The bottleneck really is for the backend application, but even there, the system is suitable for thousands of users at peak time. There will be a lot of transactions that have to be done, mainly with the in-memory database, then probably on the day itself, rather than with the PostgreSQL, the organization call that we'll have a few. But yeah, with this here, so there you need some more power. But inserting another blade, I think PowerEdge server costs around $2,000. I say, while a VMware or a Citrix consultant that needs to solve issues because you have way too many virtual machines and no rational management of them, that will cost you $1,000 per day. So 2 days of consulting. A previous organization, they were angry with that because we had to hire indeed a Citrix consultant to sort of solve something. First, he didn't solve the problem. Secondly, he worked for a month, so it cost us $25,000. euro. And I asked, like, what do we get for that? What did we get for that? This is a bad contract because, the service we expected, we didn't get it. Nothing got solved. And yeah, we lost $25,000 and or euro, and that's it. Again, I'm gonna rant a little bit and gossip. If your organization has only 5,000 employees, but your data center has 200 plus, expensive rack or blade service with the virtualization of like more than 50 it was, because said these 100 servers are distributed over 2 data centers. About 56, I think, was the virtualization called quotient or rate. Then there is something seriously wrong. So I am gonna leave it at that. Just gonna see if I have something else to present. Yeah, this I'm gonna talk next time. There are really nice things happening in Belgium. Both are platforms for the use of authentic source data and passing them on to the consumer, with really nice things in terms of data interchange, not limited to HTML pages and forms, a request response type SOAP interaction, but really data interchange protocols and formats which require innovative XML schema definitions to do here in EDPO notary acts to not transmit them as PDF files, but manage the information that is them in them, manage semi-structured data, REST type interaction through AJAX, template use, which on the server side, indeed, through move to infrastructure as code, integrate development there, better service the deployment pipelines, management of configuration with good tools, solid tools like Puppet, revamping identity and access management using indeed these killer applications like It's Me, etc. etc. And I'm gonna leave it really at that.